Hello, this is Mrs. Ellsworth. I went and put this picture of Disney's Pixar movie Up to elicit some ideas. What do you think I'm going to talk about there? I'm going to talk about those balloons. You notice that the helium balloons, that they always rise up, and that water balloons, that they fall or hang in this case. Well, why does one go up and the other one go down in air? Notice this duck, it floats in water. And notice this fish. A goldfish doesn't float. Well, if it's a live goldfish, it doesn't float. Anyway, why does one float and the other one not? This is to help come up with some ideas of what it might be, but to also help us understand density. Density is one reason for why some go up and some go down. Density is a physical property of all matter that we can use to help identify it. And so I can look at some elements, like there's the element on the left, and I measured it, and I measured its density, and I found the density to be 11.35 grams per cubic centimeter. And when I measured the density of the chunk on the right, I noticed that its density was 2.26 grams per cubic centimeter. Notice that their units are ratios. That's because the density of them is measured with a ratio. Ratios will help us understand that if I would take off one chunk off of that black piece, that its density would also be 2.26. Because the mass would be smaller, so would the volume, so the ratio of the substance would stay the same. So it doesn't matter how big your chunk is or how big your weight is. You can use these two density ratios to help you identify them. And when I looked on my periodic table, I saw that this was the same density as lead. It's heavy. Okay, and this is the same density for this carbon chunk here. It matches up with carbon. So, moving on, there's another way that I think of density. I like to think of a dense woods. That's the way that many people think of density. Density, dense, and so they use those words often too. Notice that this yard is less dense. It has just a few trees. The woods is so full that you couldn't even drive your four-wheeler through it, but yet this yard you could, because the area there does not have very many trees growing on it. Much more dense. Okay, here's another way I found these models on the internet. I thought they were quite interesting. Notice they're the same volumes, but this one's got a lot more. It's more dense. Okay, helium floats, it floats on top of water. Both of them do, right? And so does oil. It's less dense than water. I like these models, so I had to show them for you. Now, there are two ways to find there are two measurements that you need to find density. You need to find the mass of the object and the volume of the object. Now, the volume you might remember because you've talked about it many times in math. And the mass, though, however, is the amount of matter in an object. So if it's more massive, it's going to have a lot more matter in it, right? But volume is the amount of space it takes up. Okay, so to find density, we find both of these values and we put them in a ratio. Remember, it's a ratio, and it's mass over volume. We show density with a capital D, mass is with a small m, and capital V for volume. Okay, oh, wait, I wanted to show you this one other way that students like remembering density, how to write the formula every time. They put that heart there. They love density, right? And that top of that heart kind of looks like an M, and the bottom would look like a V. Okay, let's go in and look at this lead cylinder that I have here, and let's figure it out. How would we find the density of this lead cylinder? So let's practice. First of all, we would go and put, we would go and put the lead mass on top of the balance, and we would just read its mass. Okay, the volume, do you remember how to find volume in math? You would go and find it with a ruler, right? And you would go measure the radius of it and also the length of it. I'm going to change that to height because that fits that formula that you learned in math years past. Notice that it's pi. times the radius squared times the height. I myself would go and measure the diameter across and at the where it's got the furthest across and find its diameter, and then I would go and divide that number by 2 because I think that'd be a much more accurate way of measuring it. And don't forget when you're measuring these that you need to follow the rules that we used the last unit for measuring and read between those lines and figure it all out so that you're more precise. Now the balance, this precision is just straight up. You put it on the balance, you turn on the balance, zero it, and you put it on and you read 82.7 grams in this sample. Okay, and that fits nicely into our formula. Okay, but the volume, we've got to do some thinking with the volume and some calculating. So with the height, I measured that and I got 9.75 on that cylinder. And then the radius, I actually measured the diameter straight across. It was a full centimeter right on the line, so I would divide that by 2 and I got 0.5 centimeters. Now I go and I plug that into my formula. Okay, and when students do this, it doesn't matter if you put the pi button or 3.14, that doesn't matter because we got to round it at the end, and so that doesn't matter. But they forget to square this. So that's really 0.25 square centimeters times this one, and you would get a volume of 7.65 cubic centimeters. Square centimeters times centimeter, you get cubic centimeters, and that would be your volume. Okay, and so then now we can calculate it. 87.2 grams divided by 7.65 cubic centimeters. And in my calculator, I get this value here of 11.3986, blah, 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 blah. And so you just need to round to the nearest hundredth. But what kind of unit do you put on this? Well, it's grams over cubic centimeters, just like what you have in your calculation. So it's grams over cubic centimeters. And you just round it. Remember I said to the nearest hundredth. And so you get 11.40 grams per cubic centimeter. When I look on the periodic table, remember it's 11.35. So that's not bad. Okay. But on your lab report, you'll notice that you've got something going on here. So here we're going to fill in part of it for our lead mass here. And we got 87.2 grams in a volume of 7.65 cubic centimeters, and we got that. Okay, well, over here we got to still do it with the lead weight also, but you don't need to remass it, just use what you had there. But you notice that it says water displacement. Well, I found this really good diagram on the internet that would really explain water displacement, so I'm going to kind of divert you to that. So here's a graduated cylinder, and so what we're going to do is we're going to find an initial reading. And when you read this one, you read the bottom of the meniscus just like we did in the last unit. And on this one, let's say I got 55 milliliters. Okay, I'm showing precision with that 0.0, sorry. Anyway, so then you go and you put your piece of mass, or lead in this case, well, down the bottom. I think lead would be much heavier than this. Anyway, so then as it goes down to the bottom, what happens? This rises. So that is the amount of volume this mass displaced. Okay, and now it's at 70 milliliters, so 70 milliliters minus the 55, and you take notes somewhere else. Don't write this in that water displacement portion of your sheet, and that's how you find the water displacement, by finding the difference of those two. That'd be 15 milliliters in that model that I saw on the internet that I grabbed there. And I'm not going to finish filling it in because that isn't even realistic for this one. But you know how to do water displacement. I will have another video demonstrating water displacement again, and you can look that one up too. It's in the same area that you found this video. Anyway, let's think about this. You'll notice that tomorrow when you're looking at some of those cylinders, like the aluminum one is really light and the stainless steel one is very heavy, and they're the same volume. So that just tells you that how the molecules and how many molecules that are packed inside of there, that just tells you why the stainless steel one is more dense than the aluminum one. Well, I guess you need to write down the formula and keep that, but I want you to remember and bring two things to class with you tomorrow. You need to discuss with your groups why the helium balloon behaves differently from the water balloon, why the rubber ducky floats and the alive goldfish did not. And if you need to look at the water displacement video, do that too. But be prepared. Watch this as many times as you need to so that you are prepared for the lab tomorrow. And I will see you then.